this is going to look somewhat reviewish and somewhat newish because you guys have graphed parabolas before. The main things, if you want to recall, is that we had these two different formats for graphing quadratic, aka parabola equations. So this was called standard form back in Algebra 1, and you did the quadratic formula, plug A, B, and C in there to find out where the parabola crosses the x-axis, right? You also did factoring, right? When you factored it, those, like if it was x minus 2 and x plus 3, that would tell you where they cross the x-axis. And then Algebra 2, you probably also had this vertex form that looked like this, which you did have to complete the square. Right? And you had an a value in front. So you're going to have yet another way of doing this that works really well with, well, let's say numbers that are not all these perfect integer numbers, right? So what if things are fractional and things like that? There's another little method that we use that works really well. So just to review that, I don't know if you guys worked on with a focus before in parabolas, so that might be new, but the focal point is kind of how the whole parabola is created. So let's say this is the focus, or the focal point, right? Down here is a line called the directrix. These are the two that really determine what a parabola looks like. And the closer this focus is to the directrix, it can make it wider or narrower and change its shape. So you guys know the vertex, right? That's always in the middle of the two. So if you have your focus, directrix, the midpoint of those two is the vertex. Vertex. Okay. And the technical definition of what a parabola actually is the same distance from the focus and the directrix. So if I have a point over here that's on the parabola, it should be the same distance from here to here as it is from here to here. So as you can see, this one looks a little bit longer than this one. So that point would probably not be on the parabola. Right, whereas something like, let's say up here, that, like that, should be straight down. We want all these points to be the exact same. So that means we get this curve that ends up going like this. So what we're going to do is actually just use these 2 points where they intersect in order to do some graphing. Actually, I'm sorry, that should be going through the vertex, not the focus. Sorry, there we go. Yeah. So that's how that whole process works. Right? And we're going to use a couple points on either side that help you graph it. So we don't have to do a whole T-chart and get a bunch of points to graph a parabola. We're just going to use the vertex and these 2 other points that are on something called the LLR, which I'll talk about in a minute. Okay. So a fixed point is called focus, right? And a fixed line, these are the 2 parts that we just did, the focus and the directrix. One's a point, so if you're asked to find the focal point or the focus, you already know it's a coordinate. If you have to find the directrix, this is an actual line, so it's an equation. It's either going to be y equals if it's horizontal, or it's going to be x equals if it's vertical, because vertical lines start off with x equals. So it's good to know if you're asked, what's the directrix, it should be starting with either x equals or y equals. It's always a vertical or horizontal, never diagonal line for now. Okay. And we can use a bunch of parabolas to figure out really if something goes up in the air, where is it going to fall, right? That's always a good thing. They just have a soccer ball here, but more realistically, you could think of like, when they're launching SpaceX stuff up, and they always want the boosters to crash into the water so they can, pick them up and reuse them. That's why they do it over the ocean. It hits the ground, it's going to break, right? But it's nice to be able to predict where these things are going to actually fall. So when the recovery crew is waiting on standby, they kind of know where they should be, roughly looking at, wait for this thing to hit the ocean, then they can go and swoop in and grab it, right? So to predict where things are falling and where they're going to land, what's in the sky and gravity, and in higher math you can also add in the wind and all these other factors, so find out where things will actually land. So the biggest difference, though, between what you did before in Algebra 1 and what you're doing now is, for the first time, kind of like all the other conic sections that we've worked with so far, they can have different directions to them, right? So you can have something that opens up and down, right? Those will start with x, and they'll have the squared. But for the first time, you have stuff that can open left or right. Parabolas that open left or right. They're going to start with y squared. So you can see it's kind of like the hyperbola, where you can have an x or a y show up first. So just be careful about that, because, again, the vertex can be tricky sometimes. All right, so we have parabolas that open left and right. Okay. Other information. We got this new value. You could look at this. This looks all familiar. We have our vertex, right? H and K. Okay, so the first one's H, the second one's K, but it's over here. Notice how K always stays with Y. So you don't want to always say, well, the first number here is the X and the second number is the Y. You got to pay attention to which side the X and Y's are on. All right. Now, we have this new value called the P value, right? And we don't have an A value, the thing that we used to show like how wide or skinny it's going to be. We use this P value instead because it's the distance, as it says here, vertex to the focus from here to here. That's the value of P. Okay. And since it's a distance, technically it's absolute value. Can't be negative, right? And it also says from the vertex to the directrix. So I said earlier that the vertex is the midpoint of these two, right? So that means the vertex is equidistant from the directrix and the focus. It's in the middle. Equidistance means same length. So if you ever, sometimes that's just a fancy way of saying it's the midpoint. Equidistant, it's the midpoint. It's in between. Okay. Now we have this other part here, the focal width. So that goes from all the way across here. From here, all the way across. So that's the focal width. And that every single time is 4 times P. 4P. The distance, so we'll say absolute value, but 4P. So whatever number shows up right here in your equation, because there's not going to be a P value, right? It's going to be like 16 or something. That's the length from here to here, from one side of the parabola to the other, going through the focal point, going through the focus. And that's what you're going to use to graph. You're going to use these 2 points and then the vertex to do your graphing. Okay? And the rest of it, you're going to get here. You're just going to kind of wing it up there and just do your best to estimate, where it's going. It's not going to be exact, but it's okay if these, after you go through these 2 points, if it, it's not perfect, it's totally fine. All right, so positive P. So if this is positive, this 4P is positive, right? That's going to open up or to the right. All right, so if we have a x squared, it's opening up. If we have y squared, it's opening right. And if the P is negative, right, that's when it's going to open down or left. So the most mistakes, I'll tell you up front, have to do with not recognizing, is it opening up, down, left, right. It's the part that you don't do any writing. So on Monday we did the whole thing with like which conic section is it. We looked at the major axis, minor axis. You can kind of tell, is it longer vertically or is it longer horizontally, right? Hyperbolas, do they open to the left and right or do they open up and down? So the same question you asked on those, we'll ask first here. So you have a mental picture of what you're graphing or what you're figuring out, and then as you go through it, you're working towards that actual picture becoming real, okay? As opposed to, let's just start graphing it and then we'll just figure it out as we go. We don't want to do that. All right, so that being said, we're going to go through, I call this the focal width. The Latin is called latus rectum, but we just say focal width. So, but it's easier to abbreviate LLR. So when you see LLR, that's what that stands for. It's the focal width. AOS is the axis of symmetry, which goes down the middle. Right? Goes down the middle of your graph. So in this case, it's going to be an x equals because it's a vertical line. So in any given problem, if you're asked to find an axis of symmetry and a directrix, one has to be x equals, one has to be y equals, right? You're not going to have two vertical or two horizontal. They have to be perpendicular, so you have one of each every single time. All right, so let's go through and look at this one. So ask yourself, does this open up, down, or left, right? Seeing how it has the y that is squared. Look back up top. What do you notice? What say you? Left, right, horizontal. The y is squared. Horizontal. So it's going to be one of these two. And since this is a positive 8, we know from the very beginning that this should be opening left, right, or to the right. All right, so we want to have that figured out first before you do anything else. It's not a step. You don't have to fill anything else in here, but it is the first step you want to take. Okay? So from here, we can figure out what we need to. So we got our vertex, which is what? -3 and 1. Is that correct? No, that's not correct. So this is all going to be about little small details, right? So follow me as we go along. It's very easy to get caught up. Okay, here's the x, so that's the 1. Here's the y, that comes second. All right, very important detail. So we can mark that down there, okay? And now to find everything else, well, we could do the axis of symmetry. We do know it's opening left, right, so we know the axis of symmetry is going to look like this. Horizontal line goes through at -3. All right, so we got an axis of symmetry at y equal -3. Okay. So to find the focus, in order to get from my vertex that I do have to the focus that I don't, I need to know how far apart they are, this p-value. Okay. So this value here, +8, that equals 4p. So I always just take whatever this number is, equal to 4p, solve for it. That gives us how far apart everything is. So I can go 2 to the right, 1, 2. That puts me at 3, -3 for the focus. Then I can go to the other direction, right? Remember the directrix is the other direction from the focal point. So I just go back to the vertex, go the same distance the other direction, 1, 2, and there is my directrix, which is a line. And remember how I said one has to be y equals, one's x equals, so you see we have the axis of symmetry is y, horizontal, the directrix is vertical, it's x. So I always have one that's an x, one that's a y. And this is, it goes through -1 on the x-axis. And the LLR is just the number that's right here, 8. That's how far it is from one point to the other. So that means it's for one direction, for the other direction. So we go here, we go back to the focal point, not the vertex, but the focal point. I'm going to go up 4, dot it, back to focus, then down 4. And with those 3 points alone, I'm going to draw my parabola opening up to the right-hand side. not too bad, not too bad. So the next one is the same, but it's not set up in the format already. So we got to do a little completing the square. So it's a little different for everything else that we just got equal to 1 and got the number by itself on the right hand side, divided by it so it equaled 1. Here you can see we have the squared term on the left. Whatever variable it is, it goes on the left. The linear or non-squared terms go on the right. So I look at this and I have to decide, is it the x's or the y's that belong on the left-hand side? The x's are squared, so that stays on the left. The y and the number move to the other side. Is it water? And just like before, we need something, a binomial squared, a perfect square binomial, meaning I need this to happen. So whenever you need this and you don't have it, that means you have to complete the square to make it. So here, we'll do exactly that. We'll add something to both sides that makes it a perfect square, and then we'll have this format. Okay. So what is the number that completes the square? Half of -4 is -2. -2 squared is 4. Add that to both sides like always. Now we have an x minus 2 equal to a 4y plus 20. Those two combined. And the last step is, if you look at the format once again, you can see that this has no number, right? So we want to factor out whatever is in front of this variable, we factor that out. So in this case, it's a 4, so let's factor out the 4. So now we have y plus 5 on the right, and we have the x minus 2 squared on the left. And now we're back to where we need to be to graph everything. Alright, so I'll give you a second right now. Go through each one of these. You can work on it together and check as you go, or however you want. Just make sure your answers match everybody else. And yeah, go ahead and give that a shot. Let's take a look at these where we have to come up with the equations. So good idea is to definitely sketch it out, right? Because from just this we could figure out what direction's opening and whatnot. So let's see what we got. We got negatives. we got -3, +1. So let's say 1, 2, 3. +1. There's my focus. Oh no, my vertex. And then my focus is -3, -2. It's below it. -2. So which direction is this opening? It's opening down, right? So, because for a parabola, the focus is inside the parabola, right? So if this is the vertex, it can't open it up because then the focus would not be inside the parabola. So that's a good thing. So are we going to start with y squared or x squared? All right. Is it x here or y here? X, all right. That means y is over here. Okay, we got a vertex, which is what, -3 and +1. Right, is that correct? Definitely not correct. Yeah, don't do that. So look at details, right? So we got +3. -1. Good. What is our p-value? All right, so we know that the number that goes here is 4p. So if I have to figure out what this value is, I multiply it by 4. That number goes here. So what is the distance between these two? How far is it from here to here? 3. All right. So 4 times 3 is 12. Okay. Looks good. But why is it wrong? Negative. Very good. Opening down. So it's always little things. So after you do all these problems, just like you did on the Desmos, look carefully one more time at every little thing. Opening left and right. Is the x first, the y first? Opening left down is a negative, right? All that good stuff. You want to be very cautious about that. All right, so one more, then you guys got plenty of time to do some work on your own. So we got directrix of -1, vertex of 1, 2. 1, 2. Okay. So what direction is this opening? What direction is opening? To the right. So we have what? X -1 and y -2. How far is it from the directrix to the vertex? What's that distance? Remember, this is -1. It's -1. And this is 1, 2. So how far apart are they? 2. So 4p with p equal to 2 is 4 times 2. You get 8. There we go. How's that look? Yeah, it looks very wrong. So what's wrong with it? Should the y be squared? Yes, we should have it's opening this direction. So we should have y. Okay, so it should be y -1. Not just x. And then x -2. How's that? Better? No? Now it's wrong. What else is wrong? Yeah, it should be y minus 2. Right? So you don't always just take the first number, just doesn't go in the first place automatically. It goes with the proper variable. I do this because this is the most common mistakes. So I'm giving you this heads up and kind of messing with your brains a little bit after lunch because it is the most common mistake. Okay? How's that look? Almost right. What's wrong with this? X minus 1. Okay. So just try to train your brains to be very critical in what you're looking at. Look at it, look at it again, ask yourself, wait a minute, is that, let me double check, y, y, x, x, open up, open down, is it negative, positive, in front, right? Those are the little things that are going to drive you nuts on these problems. So if you can pinpoint that, and as I was doing this, you're just giving me that look of like, you really doing this again? Then you're on point. If you're just kind of copying down saying, hey, that looks great, put yourself in check before you start doing these problems so you don't have a bunch of wrong answers, right? Don't just kind of go with the flow and assume it's just some simple problem with no mistakes to be made, right? It's all little details. Okay, so you got plenty of time to work on this. We'll put up your homework.